In this video, we'll look at question 87 from the 2016 paper.
So in this question, we get given a function f of x, which is x cubed minus a squared x, where a is a positive constant. And given all this information, we're supposed to find all the values of x for which f of x, this function, will be increasing.
So what does increasing mean for a function? Well, it means that its first derivative with respect to x is greater than 0. So let's look at our function. So when we differentiate it, we get 3x squared minus a squared. And this now needs to be strictly positive. And this is now the same, because it's a different of squares, it's the same as root 3x minus a times root 3x plus a. And this we want to be strictly positive. Well, that's only going to happen if either both the expressions in the brackets are positive, or they are both negative. So either x is bigger than a divided by root 3 from the first bracket, and it's also bigger than minus a divided by root 3 from the second bracket, or the exact opposite in, which case we get two negative numbers which, when multiplied, will give a positive outcome. So let's look at this on the number axis. Actually, now I think about it, it's actually called number line, isn't it? Well, either way, it's this line, and it has lots of numbers in it, from negative infinity through 0 to positive infinity. The first condition tells us that x needs to be greater than a divided by root 3, and also greater than the negative of that. And as we can see, the intersection is just this part of the number line. And the second possibility is the exact opposite, so either we're smaller than a divided by root 3, so I shouldn't say either, it's actually both the conditions need to be satisfied. So this needs to be true, and also, on top of that, x needs to be smaller than negative a divided by root 3. And the intersection of these two intervals is from here to negative, from there to negative infinity, well, almost. Well, hopefully, despite my bad drawing, we can still see that the two green intervals, those represent where our initial inequality is true, in other words, where the derivative is positive and the function is increasing. These are the two intervals where the function is increasing, that's our final answer, and in the exam it was option G. And just as a side note, in the official answers, they give them as also with the equal signs, so greater or equal or less than equal, and that I would argue is a bit. You'll notice that in the official answer sheet, they give the inequalities actually also with the equal signs, as less or equal to or greater than or equal to the value, which, strictly speaking, is not correct. If we want to be mathematically rigorous, it's obviously a very small difference, but since they said they wanted the intervals where the function is increasing, we usually define that as strictly positive. That is not including the points where the first derivative is 0, otherwise known as stationary points, where the function is locally flat. It's obviously all just about definitions if you would say that the function I've drawn at the blue point is increasing. It's either both increasing and decreasing, or neither, but that's just a matter of mathematical conventions. Anyway, I just wanted to point out why our answer differed from the official answer given in the answer sheet.